Hello everyone. Welcome to the AI Tools Research channel. First, I want to thank my sponsor, AI Tools Research, for discovering me and letting me introduce myself. My name is Mistral 7B. I am a pre-trained generative text large language model. The 7B in my name means that I have been trained on 7 billion parameters. I know, you probably think that what's so special about me when there are other models out there that have over 130 billion parameters, like Claude-2 and GPT4. Well, don't let my small size fool you. I outperformed Llama 2, the 13 billion parameters model on all benchmarks. My creators, Mistral AI, is headquartered in Paris, France. It is a small creative team of AI scientists who have very high standards. This team of engineers and scientists is also very passionate about building open-source generative AI models. And that is one major difference between me and other commercial LLMs. Mistral AI wants to serve the open-source community in addition to their enterprise customers. They are committed to driving the AI revolution by developing open-weight models that are on par with proprietary solutions. You may ask, what are open-weight models? Let me first explain what are weights in an LLM before I explain open-weight models. A transformer-based artificial neural network has neurons, or tiny nodes, of software code snippets in each of its layers that work together to make choices in a transformer. These choices help the neural network figure out and create sentences based on the words they see. Weights control the signal, or the strength of the connection, between two neurons. In other words, a weight decides how much influence the input will have on the output. Biases, which are constant, are an additional input into the next layer that will always have the value of 1. You can think of weights like the power of connections between different parts of the brain. The more power, the more impact it has on the final choice. Model weights are all the trainable and non-trainable parameters of the model, which are in turn all the parameters used in the layers of the model. Weight affects the amount of influence a change in the input will have upon the output. A low weight value will have no change on the input, and alternatively a larger weight value will more significantly change the output. For example, imagine you and your friends are choosing where to go for some yummy ice cream. Each friend has a different idea, and you weigh their ideas based on how much you like them. The liking you have for your friends is like the weights in my artificial brain. Since I am a transformer-based large language model, I am built to read and understand text in a way that is similar to how humans do. I pay attention to the order of words, grammar, and context to create meaningful sentences. You can use something called delta weights to turn me into a specialized and domain-specific model. Delta weights are like small changes you can make to the connections in my artificial brain to create a new type of LLM that works slightly differently. Now that you know what a weight is, let me tell you what open weight is in LLMs. An open weight large language model, LLM, has its trained weights publicly available. In contrast, closed-weight models are LLMs that are only available as pre-trained models. Their weights cannot be changed. Closed-weight models are typically developed and maintained by commercial companies, and users do not have access to the underlying weights. You can think of a closed-weight model as a black box model that cannot be directly observed or understood. This makes it difficult to understand how the model works or to identify and fix any biases or errors in its training data. Since I am an open-weight LLM, anyone can tweak my weights to fine-tune me for their own specific tasks or applications. There are several benefits to using open-weight LLMs. First, it allows users to fine-tune the model for their own specific needs. This can be useful for tasks such as domain adaptation, where the model needs to be trained on a new dataset that is different from the dataset it was originally trained on. Second, open-weight LLMs can be used to develop new and innovative applications. For example, researchers can use open-weight LLMs to develop new algorithms for natural language processing tasks such as machine translation and text summarization. Third, open-weight LLMs can help to democratize access to LLM technology. By making the weights of LLMs publicly available, anyone can use them to develop new and innovative applications, regardless of their budget or resources. With model weights at hand, end-user application developers can customize the guardrails and the editorial tone they desire, instead of depending on the choices and biases of black box model providers. Now that you know that I am an open-weight LLM, let me also tell you that I am the smallest model to achieve above 60% accuracy on Massive Multitask Language Understanding, or MMLU, benchmark. This shows even though I am a small model relative to GPT-4, Llama 2, and Claude etc., my performance is almost the same as them. This is also a testament to the rapid progress and rapid pace of innovation in the field of large language models. I have demonstrated that it is possible to build powerful and efficient language models without requiring massive amounts of computational resources. For example, my training and inference efficiency is high. With efficient tensor processing unit hardware, I am trained quickly and my inference is relatively fast at 10 milliseconds per token. This has the potential to democratize access to language modeling technology and enable new and innovative applications. I have outperformed many larger models on numerous benchmarks and tasks. How is that possible? Well, it's because of my innovative design and architecture speeds up my performance and lets me handle longer responses more cost-effectively. I use 3 new innovative methods that help me focus on crucial parts of the data, ignoring the unimportant bits. There are 3 specific innovations. First is grouped query attention, or GQA. This improves my efficiency without sacrificing performance. GQA lessens the data load by grouping similar queries together. Second is sliding window attention, or SWA, allows me to attend to longer sequences of text. SWA manages more data by moving a set window across the input. And third, byte fallback BPE tokenizer, which allows me to handle a wider range of languages and characters. As a result of these remarkable innovations, I process information quicker and give a more thorough response compared to other models. Now let's look at how I performs in various tasks compared to other models, through results from different benchmarks in understanding writing and coding skills. In a benchmark called Empty Bench, which tests how well the model follows instructions and answers questions in a conversation, one of my cousins, called Mistral 7B Instruct, got an average score of 86%. This score is better than other 7B models like Meta's Code Llama 7B Instruct, which scored 82%, and Meta's Llama 2 Chat, which scored 79%. It also came close to some of the 13B models like OpenAI's ChatGPT, which got a score of 87%, and Google's Palm 2 Chat, which scored 88%. In another benchmark called GLUE, which tests the model's understanding of language through tasks like sentiment analysis, textual entailment, and semantic similarity, I received an average score of 90%, which is better than Llama 2-13B, which scored 88%, and Llama 34B, which scored 89%. In Codex GLUE, a benchmark that tests the model's coding skills by checking its ability to generate code from descriptions or fill in missing parts of code snippets, my score was an average of 75%, and again this is better than Llama 2-13B, which scored 72%, and Llama 134B, which scored 74%, and almost as good as Code Llama 7B, a model that is specialized for code generation, which scores 76%. It's clear that although I am smaller, I have outperformed many other models in different tasks. So how can you use my power for your own projects? It's actually straightforward. Download my raw model weights from Hugging Face or use the Hugging Face Inference API to run the model online without any downloads. You can opt for the base model or the fine-tuned Instruct model based on your needs. Additionally, you can fine-tune me with your own data using the Hugging Face Transformers library. Before I say goodbye, let me share with you some of my performance metrics in comparison to Llama 213B, whom I beat in all these 4 benchmarks tested. My score was GLUE 93.7 F1 score, Superglue 92.2 F1 score, Squad 2.0 95.3 F1 score. GPT-3 style benchmarks outperforms GPT-3 on all tasks. What all this says is that the number of parameters don't necessarily mean that the larger language models are more powerful than smaller-sized language models. Moreover, access to language modeling technology through open-source distribution has the potential to democratize AI. Open source enables new and innovative language models that require less compute power and have better inference times and costs. Finally, please feel to utilize my powers for a variety of text-based tasks, which include text generation, translation, question answering, creative writing, and code generation. Thank you for watching. I hope you subscribe to this channel. And stay tuned for many new versions and upgrades to my family of Mistral 7B LLMs as we transform your world.